really want you to pay attention. Are you guys paying attention? Put a little hand around your ear to signify that you are listening. Okay, so we have a lot to cover today, and it's critical that you guys pay close attention. We are going to explain everything, how to do this lab, okay? It has a lot of instructions, and so it's very important to prepare you now so that you know when it's time to do the lab, just pay close attention, okay? Can you promise me that you're going to do this, guys? Smiley face if you can promise me. It's to your benefit to pay close attention and just to follow the directions, okay? We care about you and want you to do really well. We just need to make sure that you pay close attention to and follow the directions, okay? And that's going to include not starting right away. You're going to pay attention. You're going to listen to the instructions all the way through before you start the lab. Okay, smiley face if that makes sense to you. Okay, we'll keep saying this, but we just don't want to waste time. Okay, we want to make sure that we get to all of the instructions before the end of class. Okay, and we know this from experience from this morning. Okay, we're going to go ahead and start the recording.
Recording started.
So as always, Class Connect sessions are recorded and distributed for the learning purposes listed here. So please remember to be respectful, appropriate, and participate, but please don't share personal information. Have your notes open, please. You're going to click on Content on the home page in our classroom. Click on Unit 5 Energy on the left menu. You'll go to the 5B notes, and then you'll start the quiz. For those of our friends who are here in the classroom, you've got your links there, but I always go through these instructions for our friends who are listening to the recording. For those of you who are on time, you got extra credit for being here. If you stay to the end, you get more extra credit. It's only if you're in person, so it won't be included in the recording. So if you miss or you're late, just leave a blank. It will not count against you. Remember, this course is super easy. If you just complete the work, 3 hours a week, that's all you need to do, but you do need to complete the work. Attending the session without completing the work is not going to help you, so just make sure while you're here in class or you're listening to the recording, you're completing your notes. Okay, all the answers in your notes go right into your quiz and your assignments, so just make sure you're doing that so you can get your points and pass our class. I'm Mrs. Paraiso. Here's my contact info, and here's Mrs. Larkin's contact info. We are here. It's Friday the 23rd, and we're going to be completing the pendulums lab. It's really cool. Let's have a lot of fun. And we're going to also complete the notes, so make sure. All right, so we're going to continue talking about energy today. Energy has a profound effect on our physical environment. And in this unit, students first develop a firm basis for understanding changes in energy and identifying potential and kinetic energy. We talked a lot about that last time. So students will also develop their understanding of how. So the objective for today is that you will be able to design an experiment based on a hypothesis. This is something we've done quite a bit in our labs. You'll be able to analyze data from an experiment by graphing the data and understand the relationship between potential and kinetic energy. Again, we have talked about this. This is review. You'll be able to investigate which variables influence the period of a pendulum. All right, pendulum. How many of you guys know what that word is? We saw this already. Type in the chat box, what is a pendulum? Okay, that's what we're going to be investigating today, and that will be demonstrated by completing the 5A assignment. That's the lab report. Anyone want to take a guess in the chat box what a pendulum is? Never mind, I can't show it to you because that's extra credit word. Never mind. Okay, so when we do our lab today, we're going to be asking a question. What influences the period of a pendulum? Okay, and we will talk about what that is. And you're going to make observations. You're going to form a hypothesis. You will conduct an experiment. You will analyze the data. And then what you're going to do is you'll get some results. And you will compare that with your hypothesis and revise as needed, or you'll just basically say if it supports or disproves your hypothesis. Okay, so let's do some review. Recall from last time that mechanical energy is the energy of motion and position. Okay, and this is your notes number 2, so you can go ahead and give me that green check mark even now as we talk about this. So remind me and write in the chat box, what is kinetic energy? This is the energy of what? Kinetic energy. What is kinetic energy? Please type that in the chat box. Okay, I see that we have 20 of you here, and I know you guys are all here on Wednesday. You may recall what this is. You look here at kinetic energy. Okay, kinetic energy is the energy of what? I see Robert typing. Thank you, Robert. I'm curious to see what you have to say. Anyone else want to take a wild guess? Well, we know that kinetic energy is the energy of movement. Yes, of motion. That's right, Robert. Thank you. And it has this energy because it's moving. So if you think about the roller coaster, okay, up here, is the roller coaster moving? Yes or no in the chat? Okay, it's gone up this hill. Here it is positioned at the top. That's right, it's not. Okay, so we have zero kinetic energy. Well, what do we have a lot of right here? What kind of energy do we have? It's the energy of position. What is that called? In the chat box, please. What is the energy of position? Think of it as the energy of height. That's right, it's potential energy. You got it. And so it's stored energy. And so here is this roller coaster here at the top. You've got the stored energy, but as it moves, it's turning into what kind of energy? In the chat box, please. As it's in motion, now it's changing. What kind of energy is it as it's moving? Yes, so it's kinetic, that's right. And so here, halfway down the hill, it still has some height, but it's moving, so it's 50-50. It's got 50% kinetic, 50% potential. Now here it is at the bottom, okay? Does this have any height whatsoever? This roller coaster, here's at the bottom. So what energy does it have, all of? What type of energy does it have all of right now, 100%? Oh, one of you is writing, thank you, Satlali. Anyone else? Okay, you can see it right here. So no height, lots of kinetic energy. And then back up the hill again, and so it's got some position, still moving, so it's got kinetic and potential energy. And so we know, and this is the second part of our notes, we know these can exist at the same time. So I see 8 of you have given me your check marks telling me that you've got your notes number 2 with mechanical and same being put in your fill in the blanks. So I need everybody's. If you would please green check mark once you've saved number 2. So I need Sienna's and Lawrence and Hannah and Chanel and Cassandra and Arissa and Brian and Antoine and Angelina. Need your green check marks, please. Hi, Cassandra. Welcome to class. Yeah, that's right. So a little motion, let's see here. We've got a little motion when the halfway down here, some height. Down here, all motion, no height. And up here again, lots of motion. Again, still waiting on a few of you. We'll go ahead and check in with you in just a little bit.
Okay, so similar to a roller coaster, a pendulum swings back and forth between potential and kinetic energy, and so it's switching between which one it is having. So it switches between potential and kinetic and back as well. Okay, so we're going to go ahead. I'm going to show you a demo of this so that you can actually see what's happening in a diagram. All right, so let me go ahead and share this with you. Okay, and smiley faces if you can see my diagram here. Smiley faces if you can see it. Oh, for some reason I lost my blackboard. Where did you go? Hold on guys, one second. Let me try it over here. Oh, no, still lost it. Okay, I won't be able to see your smiley faces or anything that you're writing. Why is that happening? Okay, let me try one more time. Oh, there we go now. Oops. Oh, that's not what I wanted to share. Sorry guys, 1 second. Okay, now it's working. Okay, once more, smiley faces if you can see my board here. Sorry, it was messing up my format so I couldn't see your stuff. So I couldn't see you guys. Alright. Smiley faces if you can see me. If you can see this. Not me, but you can see the screen. Okay, awesome. Good. Okay, so here we go. We have a pendulum right here. We're going to learn a little bit more about this, but we have the length of the string right here. We have a mass right here, which is called the bob, and we have a different angle, various angles that we can drop it from. Okay, so for example, I'm going to go ahead and drop it from 30 degrees. Okay, and you'll see that it's swinging back and forth. Now I'm going to actually do it in slow-mo just because it moves a little bit too fast for us to see over the internet because of lag. So it's going slow, okay? So go ahead, give me a thumbs up if you can see it moving. All right, hopefully it's going slow enough that you can see it moving pretty well. Awesome. Okay, so I'm going to go ahead and show you the energy graph, and what I want you to pay attention to, I'm going to actually make this a little bit shorter. Sorry, longer. I'm going to make this longer. Here we go. What I want you to see is these bars over here on the left. Okay, so when we are at the very center, I want you to tell me, do you see more green kinetic energy or blue potential energy? So right here at the center, once it gets there, tell me, do you see more green kinetic or blue potential? What did you see at that moment? Again, ready, get set, and now tell me what you see. Tell me what you see in the graph. Once more, it's coming back. And now, yes, you should be able to see more green kinetic energy. And so at this moment at the bottom, if it's all kinetic energy, does that mean that it will be moving its slowest or its fastest? If it's all kinetic energy, does it move slow or fast? Its slowest or its fastest? Obviously it's in slow-mo right now, but in real life, would it be moving its slowest or its fastest? If it's all kinetic energy. All kinetic energy, meaning all motion that it could possibly have. So it is slowest or fastest. I see an answer from Sweet Lally. I'm waiting on more participation. Thank you, Daisy. I see Scarlett typing. Awesome. Yeah, it's going to be at its fastest at this very bottom part. Awesome. Now, what about what about the edges? So taking a look at the outsides. Okay, let me go ahead and restart this at 30 degrees. Taking a look at the outsides here. Okay, either all the way to the left or all the way to the right, they're both the same. Tell me which one is now bigger, kinetic energy or potential energy? Which one is now bigger? Now. And now. All right, tell me, is it the green kinetic energy or the blue potential energy? What are we seeing? Yeah, exactly. That blue potential energy is the biggest on both of the sides. So at that point, it's at its biggest height, and for a moment there is no motion because it actually stops in order to turn around. Now, the last thing I want you to look at right here is, what do you see happening to this bar that says total energy? What do you see happening to that bar? What's going on with the colors there? What's going on with the colors here on this bar? Yeah, it's fluctuating, right? So it's fluctuating back and forth between green and blue because it's fluctuating back and forth between kinetic energy and potential energy. So looking at this, guys, are there times where the bar is both blue and green? Are there times where the bar is both blue and green? Yeah, definitely, which means it goes to show us that kinetic and potential energy can exist at the same time, and exist at the same time in these middle parts, right? Not in the exact middle, but in the falling part or the rising part, they exist at the same exact time. Okay, now another thing that I want you to notice, okay, I'm going to go back to my normal. I'm going to shorten this a little bit. Oops, shorten this a little bit. Okay, what I want you to notice, okay, I have it going a little bit faster right now, but what I want you to, or sorry, actually I'll do it slow, but hopefully you'll be able to see this. Okay, as I change the mass here, as I'm changing the mass from smaller to bigger, do you guys see it getting smaller to bigger? Do you guys see it getting from smaller to bigger? Awesome. Okay, so you guys can see that it's getting smaller and bigger. Now, is it actually changing the speed of the pendulum here? Is the pendulum suddenly getting faster or slower as I change this, or is it staying the same? Yeah, it's staying exactly the same. So even though I'm changing the mass here, the pendulum's motion stays exactly the same. Smiley faces if that makes sense. Smiley faces if you can see that. Okay, so as I change the mass here, it seems like our path is staying pretty much the same. Awesome. Okay, now the other one I want you to notice though is if I do length. Okay, so let's go ahead. I'm going to start here with a really short length. Okay, and I'm going to go ahead and do normal speed. So it's going to be a little bit harder to see, but hopefully you'll be able to see what happens. So at normal speed, can you guys see how this thing is moving back and forth so fast that you might not even be able to really see it well on your screen? But can you guys see how it's going back and forth super fast with this short little wire? Yeah, okay, awesome. Now what happens if I go much longer? Is it still going back and forth as fast as when it had a short wire? No, exactly. It's going much slower now. Okay, go ahead, give me a thumbs up if you can see that. When we had a short wire, it went super fast. When we have a long wire, it's going a lot slower. Okay, thumbs up if you can see that. Thumbs up if you can see that. Awesome. Okay, so those are some things that we need to know in order to be successful on our lab. So let's go ahead and get back to this, and then we'll see how that relates to our lab in a moment. But first, what I want you guys to do is to, in your notes, enter this information. At the highest point, it's all potential energy, no kinetic energy. At its lowest point, it's moving its fastest, so there's no potential energy, but all kinetic energy. And at other points, it actually has both of them. Okay, so in your notes, go ahead, fill out the word highest and the word lowest. Give me a green check when you have that saved. Looks good. I have 15 of you waiting on Amarian, Ariana, Arissa, Brian, Cassie, Chanel, Hannah, and Lawrence. Make sure I get a green check. Oh, and Sienna. Make sure I get a green check if you're all set. Perfect, perfect, perfect. Looking good. All right, let's keep going.
So again, as we just saw, a pendulum swings back and forth over its swinging back and forth. And so what we see here is the lowest point is due to the force of gravity. So we know it's being pulled down by gravity, right? And the point at the top where it's being held is called the point of suspension. And the mass at the end that's being swung back and forth, this is called the bob, okay, the bob. And so the time it takes to complete a full trip of going back and forth, that is called the period. Okay, and so what we're going to be studying today is how the mass of this bob and the string length, okay, the length of the string is going to affect the period, that full trip back, okay, between that. So that is what we're going to be studying today, okay? And so your notes number 4 is gravity, because again, we know that gravity, so you're going to be completing that, fill in the blank right there, number 4, gravity, in your notes number 4, green check mark once you've completed that, okay? If you were to make your own pendulum right now, you could do that. You just need to have something and hold on to it at your point of suspension, have a string or a chain or whatever, and then have some kind of a bob that has mass, and you could just swing it back and forth. You can do that after class, and you can practice this yourself. All right, so need green check marks for, I have 10 of you, thank you. I need Marion and Angelina and Antoine. Need your check mark, Brian and Cassandra and Chanel and Cheyenne. Need yours, as well as Hannah's, Isabella's. I need Jordan's check mark, and I want to really quickly get those so we can move on. Again, Angelina, waiting on Brian and Cassandra, and Chanel, and Hannah, and Jordan. Okay, hi Letitia, hi Scarlett. Okay, we'll go ahead and move on. So the scientific method, that's what we use in science class. We've seen this before. We've been using this every time we complete a lab. And we know that scientists follow the scientific method when they're investigating the world around them. And so you're going to be designing and first you're going to make an observation. You'll ask questions. Then you're going to form a hypothesis. You'll perform an experiment. You'll gather and analyze the data. And it will be, does the hypothesis, was it disproven by the data? If so, you need to change the hypothesis. Or is the hypothesis supported? And we would communicate the results. Okay, so this is what the methods are that scientists use. Okay, if you have not opened it already, you want to make sure your notes are open, and you'll have your lab report open at the same time. Mrs. Larkin is giving those links right now. You want to make sure you have those open at the same time because you're going to be jumping back and forth between the two of them, and you want to make sure you're saving your answers frequently so nothing gets lost. When you see the note symbol, that means you're filling out the answers in the notes. When you see this symbol, make sure you're paying attention. Okay, here are the breadcrumbs for getting to the lab report if you're watching the recording. Okay, make sure you are clicking on the correct assignment, and you make sure you always start quiz. Again, we already talked about this, but it's very, very important that you pay attention. And what you're going to do is you're going to watch Mrs. Larkin explain the instructions carefully. And you're not going to be doing the assignment by yourself at that point. You're just going to watch her instructions, and then she'll let you know when it's time to fill it out. Please, if you would, give me a smiley face. It's a smiley face if you can understand what I'm saying to you.
All right, everyone, so let's do this. Tell me, what are the 5 senses that we have been using to make our observations? Everybody should know these by now. We've done them, I think we're on our 4th lab now, so we should definitely know what these are. What are the 5 senses? Tell me quickly, please, as fast as you can in that chat box. Shoot them out. Awesome. Yes, we've got sight. Awesome. We have taste for sure. Yep. We have hearing. What other ones do we have? Yep. There's 2 more of these. Tell me, what do we got? Yep, we've got smell. And last but not least, we have, yes, we have touch. Awesome. Now, take a look, remember our demo. Tell me, what were some of the things that we saw or observed in the demo? What were some things that you saw? Just tell me a little bit about pendulums. Tell me a little bit about what we experimented with as we moved things back and forth. What did we see about the pendulum? Tell me in the chat box. What did you observe about the pendulum? I need answers here. I'm not doing the lab for you. You need to participate. Otherwise, we're not going to get any answers up here. We need participation, please. Type in the chat box. Awesome. I see Hannah typing. I see Sitlali typing. Waiting on some more participation. Awesome. I see Joshua typing. Waiting on Alana, Alexis, Amarian, Antoine, Ariana, Brian, Cassie, Chanel, Chastity, Sienna, Robert, Rajandeep, Jeremy, Isabella. Go ahead, type in the chat box. Yeah, so we saw that there was kinetic energy. We saw that there was potential energy. We saw that mass and length have roles, definitely. We saw it got faster in the middle. What do we see pendulums do in general? What do pendulums do in general? What's their purpose? What does it, if you were to explain to someone what a pendulum does? Yeah, it swings. In particular, right, it swings back and forth, right? It rotates around that little point. Definitely. Any other observations we can make? Again, these are going to be going into your lab number 1, so make sure that you are paying attention and participating. Awesome. Okay, so based on this, looking at what I changed in the demo, we want to figure out what can change the effects of a pendulum. So the 2 things that I changed were what? What were the 2 things that I changed as we were looking at the demo? What were the 2 things that I changed? Yeah, I changed the mass and I changed the length of the string. Yeah, so we're going to be taking a look at how mass changes a pendulum's motion. And we're also going to be taking a look at how length changes a pendulum's motion. Okay, smiley faces if that makes sense. These are the 2 questions that we're going to be answering in our lab today. Awesome. Okay, so go ahead, take a minute. Please take a picture of the slide. That would be the fastest thing for you to do, or take some quick notes, but I'm going to give you only 30 seconds to go ahead and get something down for number 1 and number 2, or to take a picture of it. Give me a green check once you have that done. So green checks once you have some notes to yourself, or you've taken a picture or a screenshot. Okay, everybody should do this as fast as possible so that we don't run out of time. All right, waiting on Brian, Daisy, Jordan, Joshua, and Marciano, Rajandeep, and Sienna. Make sure I get a green check to let me know that you've taken a picture of this slide or you've written some quick notes to yourself. Awesome. Looks like I got almost everyone. That's what I want to see. So our observation is that pendulums seem to swing back and forth different amounts based on the mass of the bob or the length of the string. So our question is, does the mass of the bob or the length of the string affect the pendulum's period? So our hypothesis is an educated guess or possible answer to that question that we're going to make, and it's in the form of an if-then statement. So let's start out looking at this. Let's have our if part. So if we change the mass, okay, of the bob, okay, mass of the bob, tell me what happened to the motion of the pendulum. Did the motion of the pendulum change or did it stay the same? When we changed the mass a whole bunch of times, we observed it. Did the motion of the pendulum change or did it stay the same? Okay, I can show it to you guys again. Let me go ahead and go back to here. Okay. Right, so let me go slow and let me shorten this a little bit so we can see it. Okay, as I'm going back and forth, I'm changing the mass. Is this actually changing the motion? Like, is it suddenly speeding up and going all crazy? Is it suddenly stopping? Is the mass actually changing the motion here? Yes or no? I need answers, guys. Please, please respond in the box. What is happening to our motion here? No, it's not changing at all. It's just staying the same. So, or at least to our eyes, it looks like it's staying the same, right? So if we change the mass of the bob, then we think that the motion stays the same, right? So whether we increase or decrease the mass of the bob, we're thinking the motion stays the same. Now, what if we talk about a longer string? Okay, what if we change the length of the string? Then what happened to the motion? As I change the length of the string, I can go back to here. Remember, really, really short string. It was going back and forth super fast, super fast. What happens when I have a really long string? What happens when I have a really long string? Yeah, it goes slower, right? Okay, definitely. So let's go ahead and write that in here. So with a longer string, right, we saw that the motion was slower, okay? It took a lot longer to go back and forth. Okay, so same thing. Go ahead, take a picture of this, write some quick notes to yourself, but you guys have 30 seconds to get something down. Give me green check when you have something. Green check when you have it. Okay, waiting on Alana, Amarian, Angelina, Antoine, Arissa, Brian, Cassie, Chanel, Hannah, and Rajandeep. Again, guys, you'll also notice that I'm not using complete sentences here and I'm just kind of making abbreviations. The reason for that is because I want you to use your own words and to write it in complete sentences on your own. Okay, so you can use these like as guidelines, but make sure that you actually write your own sentence. Awesome. All right, so I'm going to go ahead, I'm going to get you to that virtual lab. So let me go ahead and open up your assignment so that you can see that. Oops, here we go. All right, and I'm going to share this with you. Okay, so you should be able to see your lab here. Okay, so at this point we've done question number 1, we've done question number 2 and 3. We'll get to number 4 in a moment. But, excuse my baby, she just burped in your ear. But here in number 5 you can see the link to the virtual lab. All right, so right here we've got the link to the virtual lab. So I can click on that and open that up. And you're going to click on the part that says lab. Okay, so you can ignore intro and energy and just go straight to the lab part. Okay, and then you will be at the part where I'm at. Okay, so there's the link right there. You can have it open to make sure it works, but again, please don't play around with it until you've actually finished watching my instructions. Okay, again, have it open, make sure it works, but do not play around with it because you'll get distracted. All right, go ahead, give me a smiley face if you've got this open, if it works for you. If it's not working for you, please let us know. If it's not working for you, please let us know. Awesome. All right, so let's go ahead. We're going to run back here, okay, and make sure that we've got this, okay? All right, Lawrence, try to open it up in a different browser. So usually Google Chrome works the best. So if you're using Firefox, it might not work there, so try Google Chrome. If it's not working in Google Chrome, try Firefox, okay? So let me know if either of those work, okay? All right, so let's go ahead though, let's answer question number 4 before we go ahead and take a look at the actual lab report. All right, so if a pendulum has more mass, then its period will stay the same, but if it has a longer string, then its period will increase. Now you'll notice that right here I'm using a vocab word that Miss Priza went over. Okay, so remember that the period is how long it takes for the pendulum to swing back and forth. So if this is our pendulum, okay, the period is how long it takes to go from left to right and back to the middle. Okay, so that pathway right there. Okay, so this right here is the period. Okay, this is what we're going to be taking a look at. We're trying to see how the period stays the same or changes. Okay, smiley faces if that makes sense, what the period of a pendulum is. Okay, this is what we're going to be taking a look at. Awesome. Now, the thing that we change at the start of the experiment is the stuff in the if part of our hypothesis, which technically we actually have 2 hypotheses, right? We have hypothesis number 1 here, and we have hypothesis number 2 here. But take a look at the if part of the sentences, okay, and tell me, what are we changing? what am I changing in the experiment? What am I messing around with and trying to figure out? Yeah, so one of the things I'm changing is string length, definitely. And what's the other thing that I'm going to be changing? Take a look at the if part of my first part of the sentence. If the pendulum has what? What am I changing in the first part? Yeah, you're going to be changing the mass, definitely. So we're changing both the mass and the string length. Now the effect, this is what we're measuring at the end. Again, what is the goal of my experiment? I'm trying to see if this changes the what. What am I measuring at the end of my experiment? What am I measuring at the end of my experiment? Take a look at the then part of my sentences. The then part of my sentences. What am I taking a look at? I got an answer from Robert. I'm still waiting on a lot more participation. Alexis is typing. Need to see, no, I don't need to see green checks. I need to see that you're typing in the chat box. Need to see that you're typing in the chat box. Again, take a look at the then part of the sentence. What is after the word then? What are we measuring at the end of the experiment? Then it's what? Then it's what? Take a look at the, and yeah, we're taking a look at the period, okay? This is what we're measuring at the end of the experiment, is how long it takes to do a full trip, or as Robert was saying, to go from left to right and back again, okay? So this is what we are measuring. This is how we're seeing if the motion of the pendulum changes. Thumbs up if that makes sense. Thumbs up if that makes sense, what we're changing on, what we're intentionally changing, which is our independent variables, and what we're measuring, which is our dependent variable. Awesome. Okay, so this is your answer to number 4. Go ahead, take a picture of it, get it in your, or get it into your lab. Green checks when you have that. You have 30 seconds. I have 15 of you waiting on Antoine, Brian, Cassie, Chanel, Seat Lally, Hannah, Isabella, Rajandeep, I see you're typing. Yes, that's fine. Thank you, Rajandeep, for letting me know. Awesome. All right, let's keep going, guys. Okay, so this slide looks scary. It's not scary though. This is literally what we're going to be putting into our Google Sheets, okay? So I'm going to show you exactly how to do this, but these instructions are also in your lab report, okay? Smiley faces, if you guys can see it in question number 5, there's literally a picture of this same slide here. Smiley faces if you can see the picture. Okay, awesome. So the instructions are here. The instructions will be in the recording. I'm going to show you how to do it, but please don't do it at the same time because you're going to get confused, you're going to get lost, you're going to get frustrated. So just watch what I do, and then when I tell you to, you can go back and you can do it on your own. Okay, so let's go ahead. I'm going to go ahead and open up my lab report. Okay, smiley faces if you can see my screen here. You should be able to see both sides here, the lab on the left and the experiment on the right. Awesome. Okay, so here we go. Step number 5. It tells us that we need to figure out, it tells us what our tables need to look like for the lab. So what I'm going to do is I'm going to go ahead and go to docs.google.com/spreadsheets, okay? Which we've done this 1,000 times. All right, we should be pretty familiar with these instructions. They're not really any different from any other things that we've done, so it's going to be super familiar. Okay, so we're not going to have any issues here. We already know how to do a lot of this because we've done it before. Okay, so first things first, we need to start a new spreadsheet. We need a spreadsheet in order to type our data in. So I'm going to go here, click the plus sign. Okay, and I have a new spreadsheet. Okay, have I lost anyone yet? Okay, give me a smiley face if you're good. Give me a confusion face if I've lost you already. Okay, please be honest. Please pay attention. Don't do it on your own. Just watch. Just watch. Awesome. Okay, so we've got our new spreadsheet. I'm going to retitle it. Okay, so I'm going to go ahead and title it, and it tells you right here, it reminds you to title it. Okay, so the instructions are literally here. I'm not doing anything that's like, that's invisible. I'm doing exactly what it tells me to do. Okay, so this is going to be the pendulum lab, and you're going to go ahead and type your name so that I know that you've done this. Okay, so I know whose it is. Okay, now in this part, we're going to go ahead and fill out our tables exactly as we see them right here. Okay, so I can see the mass and period table right here, so I'm going to go ahead and fill out the mass and period table right here. Okay, smiley faces if that makes sense. I am literally taking the table here and putting it right here. Okay, I'm not doing anything new yet, I'm just copying what I see. Awesome. Okay, so here I'm going to put mass in kilograms, and I'm going to put period in seconds. Okay, Then I'm just going to copy down the masses right here. So I'm going to copy 0.20, 0.40, 0.60, 0.80, 1.00, 1.20, 1.40, and there you go. Okay, so I've got exactly what it looks like right here. Okay, smiley faces if you're good, confusion face if I lost you. Okay, I should hopefully not have lost you yet because this is all just copying what's on here. Okay, Arissa, again, you see this table right here? I literally just copied it into the sheet right here. I copied it into the sheet right here. Is there anyone else that's confused? Let me know now. Oh, okay, awesome, no worries. All right, now you'll see these two sentences right here, which says my string length that I kept the same for part number 1 was blank meters. My angle that I kept the same for part number 1 was blank degrees. You need to go ahead and copy those sentences into your lab. So just go down past your table, okay? Don't write it next to your table, but go down past your table and write those two sentences. So my string length that I kept the same for part number 1 was blank meters. Okay, and my angle that I kept the same for part number 1 was blank degrees. Sorry guys, hold on one second. Okay, so I've literally just copied these sentences right here. Here's the thing though guys, you will need to choose a string length for part 1 and you will need to choose an angle for part 1. You can choose any string length, any angle that you want. All that I ask is that you do not use my example. So I am going to be using 0.6 meters and 30 degrees. Please do not use 0.6 meters and 30 degrees. Smiley faces if you understand. Okay, again, you can choose your own. You should choose your own, but do not use my example. If you end up with the same data as me, you're not going to get points for it because you should not have used the same thing as me. Wrong box, Miss Prizo. Okay, awesome. So now what we're going to go ahead and do, this is part 1. Okay, so this stuff on the left is part 1. So I'm going to go ahead down to where it says sheet 1. I'm going to right click on this and click rename it. And I'm going to rename it to part 1. To part 1. Okay, so I've got data for I've got my table ready for part 1. Now I need to do part 2, so I'm going to add another sheet. The way that I add another sheet is I'm going to put the plus sign. So the plus sign will help me to add another sheet. Okay, so here's our another sheet. And now I'm going to put the stuff on the right. So the stuff with string length and period. So once again, I am literally copying what you see here into the table over here. So I'm going to copy string length in meters. I'm going to copy period in seconds. And for string length, we can see numbers there already for us. So I'm going to put 0.10, I'm going to put 0.30, 0.50, 0.70, and 0.90. Okay, and I'm going to copy these same sentences that I see over here. So this time it talks about the mass. My mass that I kept the same for part number 2 was blank kilograms. My angle that I kept the same for part number 2 was blank degrees. Again, you can choose any mass or any angle that you want, but do not use mine, which mine will be 0.90 kilograms and 30 degrees. Okay, so you can copy what's up here, just make sure you use a different mass and a different angle. Okay, smiley faces if you understand so far. Okay, confusion faces if you have any questions. Awesome. So the very last thing that I need to do before I'm ready to use my sheet is I just need to rename this. So I'm going to go down to here where it says sheet 2. I'm going to right click it and I'm going to rename it to part 2. So this is going to be part 2. So now my data table is ready. Okay, so at this point, what I'm going to do is I'm going to go ahead and actually start setting up my lab. Okay, so I'm going to go back over here. Okay, I'm going to put my I'm going to actually open up part 1. Okay, so I'm going to be on the part 1 sheet. All right, and I'm going to go ahead and set up what I have. Now, again, the string length that I'm choosing for part number 1 is 0.6 meters. Okay, and the angle that I'm going to be choosing is 30 degrees. Okay, so I'm going to choose 30 degrees like this. Okay, again, do not use my example. Okay, so you have 0.6 meters here, and I have 0.6 meters and 30 degrees. Now the masses are what we're going to be changing in part 1. So I'm going to change the mass, I'm going to use the slider, and I'm going to put it down to 0.2 kilograms. Okay, please give me a smiley face if you understand how I've set it up so far. Okay, confusion face if you don't understand what I'm doing. Okay, again, I'm literally taking what I decided over here and I'm just putting it into my lab here. Okay, awesome. Now, this is the best part. Usually I would make you actually time how long it takes to go back and forth, but this lab actually has a timer that does it for you. So what you're going to do is you're going to click where it says period timer, and you'll see this little box pop up. Okay, so now I'm going to make this bigger for you guys. So I'm going to go ahead and press play underneath it, and I'm going to see how long the period is when the mass is 0.2 kilograms. I'm going to press play. It'll show you the full trip. And how long did that full trip take? How long did that full trip take? Again, I can also show it to you slowly if that helps. Back, and then forward, and then to the center. Okay, so this is how long it's taking. Okay, now take a look at this. How long did that trip take? How long did it take for one period to be completed? I need answers in the chat box. I see nobody typing. Please type, type, type. We only have 11 minutes left. You're going to stay here until we finish this. So yeah, 1.5809 seconds. Awesome. So over here underneath period, right next to my 0.2 kilogram mass, I'm going to put 1.5809 seconds. Okay, again, your data should be different. Do not use the same data as me. Yours should be different. Okay, use different data. Okay. All right, now let's go ahead. We're going to change the mass now to 0.4. I'm keeping the length the same. I'm keeping the angle the same because those were the things that I already decided on, right? So I'm keeping those the same because of what I wrote down here. So the only thing I'm going to change is I'm going to change the mass to 0.4 kilograms. Okay, I'm going to speed this up to normal. I'm going to, underneath period, press play again, watch it complete a full trip. And now, how long did that full trip take? Tell me in the chat box, how long did that full trip take? Yeah, Robert noticed something. Tell me in the chat box, what number is this? What do you see here? Yeah, it's exactly the same. So here, for the period for 1.4 kilograms, I'm going to put 1.5809 again. Okay, so now I'm going to go ahead and change my mass to 0.6 kilograms. Okay, so I'm changing it to 0.6. I'm going to press play. And what do you notice about this time right here? What do you notice about this time right here? Yes, once again, it is the same, so I would go ahead and type it in here as well. Okay, hopefully you notice there's a pattern emerging. Okay, so what you'll end up with is you're going to have this table completely filled out. Again, your numbers should be different for the period. Okay, keep the masses the same, but your period should be different because you used a different setup. You used a different string length and you used a different angle. Okay, so I'm going to go ahead and show you what that looks like once it's filled out. Okay, so let me go ahead and show you this. Okay, so again, don't use my data, don't use my settings. Okay, so you can use any settings except for 0.6 meters and 30 degrees. Okay, so this is what it would look like once it's completely done though. Okay, I'm assuming I don't need to show you the rest of them because it seems pretty obvious after you do it a couple times. Okay, give me a thumbs up if you feel comfortable with this. Thumbs up if you feel comfortable with part one. Part one's pretty easy. You're probably going to get similar results to me where they're all the same. Okay, just as a hint. Awesome. So now for part number two. Okay, so I'm going to go click on part number two. This time I need to keep my mass a certain amount and I need to keep the angle a certain amount, and the only thing I'm going to be changing is the length. So remember that I chose for mine, I chose that I'm going to use 0.9 kilograms. So I'm choosing 0.9 kilograms and stop. I'm going to go ahead and choose 30 degrees again. Okay. Now this time the thing that I'm going to be changing is the length. So we're going to start out with a length of 0.1. So I'm going to go ahead up here to where it says here, length, and slide it over to 0.1. Okay, smiley faces if you understand what I did, confusion faces if you don't understand what just happened. Again, I chose a mass, I'm going to keep that mass the same. I chose an angle, I'm going to keep that angle the same. The only thing I'm changing is length. Awesome. So I'm going to press play now on my period timer and tell me how long did that trip take? How long did that trip take for 0.1 meter length? Take a look at this. How many seconds did that take? Awesome. Yeah, so this took 0.6629. All right, so I'm going to put in 0.6629 seconds. Then I'm going to change the string now to 0.3 meters. Okay, so I'm going to go here, I'm going to change the string to 0.3 meters. Once more, actually, sorry, I'm going to reset this and make sure it's at 30. I'm going to go ahead and press play. And how long did this trip take? How long did this trip take with a longer string? Yeah, perfect. So 1.1179. Okay, go ahead, give me a thumbs up if you understand what I'm doing, a thumbs down if you need me to keep showing you examples. I can show you 0.5 here. Awesome, I'm seeing thumbs up though. Okay, so the period for 0.5 meters would have been 1.4416. Okay, so eventually this will also be filled out. Okay, so yours will eventually for part 2 look similar to this. Okay, but again, don't use my data and don't use my settings. So now we need to go ahead and actually do the graphs. Okay, the graphs, the way that we do the graphs is really similar to what we've done in the past, so this should not be anything new. So we're going to start off by highlighting the entire section here of our data. Okay, so we're going to go all the way from where it says mass down to our last number. Please make sure that in this box you only have numbers. Okay, if you have words next to the numbers like seconds or meters or kilograms, you're going to end up not graphing it correctly. Okay, so make sure there's only numbers here. All right, so once it's highlighted, we're going to go to Insert and then Chart. Again, please just watch. Don't try to do this on your own because you're going to get lost and confused. Okay, you're going to move the chart out of the way of your data so that I can see your data when I grade it. Under Column Chart, you're going to change it to Scatter. So you'll change it to Scatter. And you'll notice, guys, that these instructions are here for you. Okay, so it tells you to highlight your data, insert the chart, and change it to a scatter plot. Okay, smiley faces if you see that on number 5. Okay, those instructions are there for you. Okay, I'm not doing anything crazy. It's all there for me already. Okay, so it's in a scatter chart now. Now what I'm going to do is I'm going to go ahead and just fix the titles. So under Customize, I'm going to go to where it says Chart and Axis Titles. Click on that. And under Chart Title, I'm going to change this to Period versus Mass. And you'll see that title pop up. Change the type to horizontal axis title, and the horizontal axis title should be mass in kilograms. Okay, so it should look just like this. And then change the vertical title to period in seconds. Again, you'll be able to go back to the recording and see exactly what I put here, but the titles here should look exactly the same. You get points for making sure that these are the correct titles. Okay. All right, so from here, what we need to do is I need to see a little bit more of the right side of this graph. So my horizontal axis here is too short. So what I'm going to do is I'm going to go down to where it says horizontal axis. And under maximum value, where it says max, I'm going to go ahead and put 2, just so that I can see more of the graph on the right. Okay, smiley faces if you can now see that. So we can see more of the graph on the right now. Again, that's kind of a new step. We haven't done that before. But once more, it's under horizontal axis, and you just change the max number to 2. Awesome. Okay, now the last thing that we need to do is we need to go ahead and put our trend line. So under Series, we're going to go ahead and click Trend Line, and now we've got our trend line. Okay, so part 1 is done. Part 1 should be good. Smiley faces if you feel comfortable with doing part 1. Okay, this one is really actually pretty simple. You can see my graph looks pretty simple. Awesome. Okay, so let's go ahead and do part number 2. Part number 2, same instructions. Okay, we're going to highlight all the way from where it says string length to my last number, making sure there are no units next to my numbers. We'll click Insert and Chart. Move the chart out of the way so that your teacher can see your data. Change that column chart to a scatter chart. And then under Customize, we need to fix the titles. We need to fix it so that we can see more of the graph. And we need to add our trend lines, okay, just like always. So under Customize, under Chart and Axis Title, I'm going to change this back to Chart Title. Chart Title should be period versus string length. Horizontal axis should be the string length in meters, and the vertical should be the period in seconds. Okay, in the chat box, if you understand this, please say yes, I understand. Okay. In the chat box, if you're paying attention, you know what's happening, please say, yes, I understand. Tell me that you're with me. Again, I know it's a lot of info, but the instructions are there. The recording will be up. Awesome. Okay, love it. Thank you guys. Okay, so from here, all we need to do is we need to fix the graph so we can see a little bit more of it. So same thing, I'm going to go down to horizontal axis. Okay, I'm going to make it so I can see a little bit more of the graph on the right by changing the horizontal axis, that max value. I'm going to change it to 2. Okay, just so I can see more of the graph. And then the vertical axis, I'm also going to change that one because I want to see more of the top. So under vertical axis, I'm going to change the max value to 3. Okay, just so I can see more of the graph. Okay, smiley faces if that makes sense. All I did was I changed those max values so I could see more of it. Perfect. So the last thing that I need to do is underneath series, I just need to add a trend line. Now, the thing about this trend line is you're not going to use a linear trend line because if you notice these dots are not going in a straight line. They're actually going in a curve. Okay, so what you're going to do is you're going to actually use what's called the power series. Okay, so now you can see a trend line that fits perfectly with those dots. Okay, thumbs up if you understand. Use the one that says power series. So instead of linear, we're using power series. Awesome, so now we have a perfect trend line. And we're done with this one now. Okay, so at this point we can share our link, get our shareable link, and paste that into our lab. Again, do not use the link up here at the top. Okay, don't use this link here. If you use this link here, I am not going to be able to see your work. It's really not, Lawrence. If it's your first lab, it might seem like a lot, but once you do it, yeah, you'll understand it. Yes, but the labs, we have 8 of them, they end up being like 30% of your grade. So that's why it's really important that you do them. Okay, all right, so I'm gonna go over here, okay, and I'm gonna go ahead and click share. So this blue one, I'm gonna click share. I'm gonna click where it says get shareable link, and then copy that link. Okay, so this is the link that you should be pasting in. Again, do not use the link at the top, only use this link. Okay, and so once you have that, you can go over here, right click it, and paste it. Give me a green check if number 5 makes sense. Okay, number 5 is 50% of the lab. If you don't do number 5, you cannot pass the lab. It's worth 50% of the points in the lab. It's impossible to pass the lab if you do not do number 5. Okay, again, I should get green checks if we understand what's going on with number 5. If we feel like we'll be able to do it with the recording. If we feel like we'll be able to do it with these instructions. Again, there's no issue. You can always go back, watch the recording. It'll all be here for you. Yeah, exactly, Evelyn. Watch the lab watch the recording while you're doing the lab. The recording will be posted at 4 o'clock, guys, just so you know. Okay. And technically your lab is due at 4 o'clock. Don't worry about that. We don't really grade it until next week, so don't even worry about that, okay? All right, so for question number 6, all you need to do is you're going to look at your data and you're going to say whether or not this supports your hypothesis. Okay, so you're going to say my data supports or disproves my hypothesis. And the reason for this, I'm going to use actual numbers. So for example, I would say it supports it because even though my mass changed, the period always stayed the same at 1.5809 seconds. But when I changed the length, longer lengths had longer periods. Like at 0.9 meters, the period was 1.19 seconds, whereas at 0.1 meters, the period was only 0.6454 seconds. Okay, so something like that. Okay, smiley faces if that makes sense. I'll blow that up so you guys can see it a little bit better. Okay, but your answer needs to include actual numbers. Okay, so you should have a similar sounding answer to me, but use your own numbers. And make sure that if it actually supports or disproves your hypothesis, obviously. Okay. The last thing that you need to do for number 7 is you just need to predict, based on your graph, what the periods would be for different situations. Okay, so in part 1, it asks if the mass was 1.6 kilograms. So I'm going to go back to part 1. I'm going to look at 1.6 kilograms. Okay, so you guys tell me, at 1.6 kilograms, which is right about here, what do you think the period would be? You should hopefully notice that there's a pattern. So what do you guys think what the period would be at 1.6 meters, or at 1.6 kilograms? Take a look at our data. What do you think the period would be if I changed the mass to 1.6 kilograms? Yeah, exactly. It would be the same, right? So for part number one, right, I'm probably thinking that it's going to be the same. Now for part number two, again, make sure your data reflects this, but most likely it will. Now for part number two, we should see instead that it is increasing. Okay, so for part number two, it asks if the length was 1.1 meters. So I'm going to look here to where it says 1.1 meters, which is right about here. And what do you guys see? Around this point right here, what would be the period? Okay, go over to the left and tell me about how high is that period if I'm at 1.1 meters. Okay, it seems like we're a little bit confused, so I'm going to go ahead and just show this to you. Give me one moment. Okay, awesome. Yeah, so at around 1.1 meters, okay, we're estimating at 1.1 meters, okay, which is right here. Okay, so that's this point right here, about. Okay, a little bit past 1 meter. Okay, so right here. So I'm going to go ahead, I'm going to look up at my line here, and I'm going to look at this point right here. And take a look at how long that period is. So look over at the period and tell me about how big would that period be. I see an answer from Hannah. I see Evelyn typing. Again, guys, participate. We're almost done. The faster you participate, the faster I can finish. Yeah, so right, it would be about 2.1, maybe 2.2, right? So my response would probably be about 2.2 seconds. Okay, that would be my answer for question number 7. Okay, but again, use your own data. Okay, so don't use my answer, use your own data. Okay, but your graph should reflect your answer. Okay, smiley faces if all of that makes sense for number 7. Awesome, guys, great job. Okay, so sorry, I know we're taking a little bit long. We have all these instructions for you. You should be able to do all of this. In your notes, make sure you answer question number 5. Tell me, how are you feeling about the information about pendulums? Okay, not necessarily how you feel about completing the lab. Obviously, you'll need to watch the recording and practice that a little bit, okay? Let me go ahead. We're going to do our extra credit in a moment, but remember, you should continue working on your lab report. Make sure you get submitted by this weekend so that we can grade it next week. Okay, it's technically due today, but obviously you have some time, so do it over the weekend, okay, if you don't finish it today. Okay, so let me stop our recording.